now do electrostatics, number 12. And in this problem, it says we have sphere A located at the origin, and it has a charge of 2.0 times 10 to the negative 6 coulombs. So I'm going to put these on an axis. So this will be sphere A, and it has a charge of 2.0 times 10 to the negative 6 coulombs. Then it says sphere B is located 0.6. So this will be sphere B, which is at 0.6 meters on the x-axis, and has a charge of negative 3.6 times 10 to the negative 6 coulombs. And finally, charge C, I'm just going to put it out here, so charge C at 0.80 meters, and charge C has a charge of positive 4.0 times 10 to the negative 6 coulombs. Based on these charges, it says, what is the net force on sphere A? So what's the force on A? Well, the force on A is just going to be the sum of the force on A from B plus the force on A from C. So it's the sum of the forces. So in this case, what we have to do is first of all list the quantities, then list the equations. So the first thing we do is write down all the initial variables. So Q sub A is equal to 2.0 times 10 to the negative 6 coulombs. Q sub B is going to be equal to negative 3.6 times 10 to the negative 6 coulombs. Q sub C is going to be equal to positive 4.0 times 10 to the negative 6 coulombs. And the radius between A and B is going to be equal to 0.60 meters. And the radius between A and C is going to be equal to 0.80 meters. Now, looking at the force of A on B, so calculating force of B on A, actually, what we have, the formula for this, is going to be K times Q of A times Q of B over the radius between A and B, quantity squared. Plugging in some numbers for this, we know that K is going to be equal to 9.0 times 10 to the 9th, and that is going to be newtons meters squared per coulomb squared, or the units. So that's K times Q of A, which is 2.0 times 10 to the negative 6 coulombs, times Q of B, which is going to be negative 3.6 times 10 to the negative 6 coulombs. And this whole thing's over the radius between them, 0.60 meters squared. Multiply that out, and I get that the force on A from B is going to be equal to negative 0.18 newtons. And it's an attractive force because they're opposite charges. So attractive force between the two, which means it will be to the right. In other words, A is attracted towards B. Now, if we look at the force on A from C, that's now going to be K, which is the constant, times Q sub A times Q sub C over R A C squared, the distance between them squared. So this one's going to be 9.0 times 10 to the 9th, and that's the Newton meter squared per Coulomb squared, times Q sub A, which is 2.0, times 10 to the negative 6 coulombs, times Q sub C, which is now 4.0, times 10 to the negative 6 coulombs. And the whole thing's over R sub AC squared, which is going to be 0.80 meters squared. All the units do match up. So the force on A from C is going to be 0.1125, a positive value. It's a repulsive force on A, and that's newtons. So it's repulsive. So it's going to be to the left. So we're going to look at its positive forces are going to be to the left in this case, and negative forces are going to be to the right. So now I just add up the forces. The force on A is going to be equal to F of AB plus F of AC, which is going to be negative 0.18 newtons plus 0.1125 newtons. So the force on A is going to be 0.0675 newtons. And since it is positive to the right, so all you have to do is add up the individual forces in this particular problem.